let's get started. Digital design and presentation. As you know, today we have an exam. And the issue is digital design process and presentation. So this one gonna be very useful for your actual final project, what you have to do for this final project. So here I list up briefly what to do today. Lab exercise number 0 is AutoCAD drafting. As an assignment from the last week, you have to submit this within the course in the lab exercise hours, not now. Lab exercise number 1 is autodeskhomestyler.com. I'm going to show you what is it, including this lecture slide. And number 2, project development. Lastly, taking the midterm exam. What we're going to do next week's 2 more weeks before final presentation. In lab exercise hours, we're going to do developing your final project using various software, what we have experienced in this semester. AutoCAD for mostly developing 2D floor plans, even if it's 3D software. AutoCAD is also 3D. But we're going to use 3D modeling, geometric modeling using SketchUp. Also, V-Ray plugin for making visualizations, Photoshop, retouching your final output images, PowerPoint as your presentation tool. And even more tools available out there, such as homestyler.com we're going to use today, or Prezi, and so on. So lab exercise hours in the course next week and next after next week, individual project development using various digital design tools with me, okay? With possible some of your friends who choose same subject. Anyway, we're gonna determine what to do for your final project today. Here is a notice. We have scheduled guest lecturers, lecture series, mandatory show up, mandatory participation required. Next week and next after next week, we're gonna have 3 hours or 2.5 hours. What other 1 or 1.5 hours? Those 2 guest lecturers, lecture series. Today's topic, how to visualize, develop, and present your design. This is the topic of final project, your final project, to maximize your design tools, quality, and capability. We already learned this one when we are dealing with design mode. In mode of thought, what is mode of thought? Design is a plan. It's idea. It's abstraction. The keywords are here: plan, ideas, abstraction. When we are dealing with mode of thought in your brain, but in mode of expression, design is also a way of taking system to make visual equivalence between which one and what? Between your idea and your product. That could be AutoCAD plan, 3D Studio Max rendering, or SketchUp model, okay? Exploiting a medium's unique quality to maximize meaning. Maximize meaning means maximize its capability, maximize its quality. If you are very, very good at hand drawing, you can draw something by your hand and present it using your hand drawing sketch. If you are very skillful at using SketchUp, you can do everything using only SketchUp. But anyway, you don't need to stick to just one software. We can use a lot of software, including software we didn't tackle in this semester. You can learn by yourself. You can take a look at, you can gather some information about it. So to maximize your design tools quality and capability is one of the answers how to make it. If so, what tools you're going to use? By hand or by computers? I think both, okay? You can draw it. You can draw some diagram and scan it, convert it into kind of digital image using Photoshop or even AutoCAD, whatever. So let me show you some series of examples today, design and design development tools. But before showing you some series of examples of design presentation, we need to pay attention to design tools, design development tools, bunch of tools we already experienced, even if they are some part of it. Anyway, you know what is SketchUp, at least how to use them to model your 3D surface-based model. But newer version always evolving as time goes. Understanding mechanism rather than knowing tools simply means that you don't need to stick to memorize the sequence of clicking buttons or pull-down menu system. That's just the GUI, user interface issues. That's what I told you before. You have to know background theory behind technologies, so-called mechanism, how it draw whatever you want in SketchUp or AutoCAD, and so on. Even 2D, 3D, whatever. That's my basic idea. A lot more easy and powerful tools out there. Two examples. First one, homestyler.com. This is a web-based application. Today's lab exercise one is this one, homestyler.com. Today, we're going to use this website and try to make this building like building shape. And then you can easily convert it into 2D, 3D CAD DWG file, as well as amount of visualization, such as, here is an example, this one, rendered by web cloud servers. Chief Architect, one of the famous design tools. We're not going to deal with this one, but you can refer to the website. Just for your information, let me try to open the website, Chief Architect. Okay, this is chiefarchitect.com. Let's take a look at one of the software tools among series of Chief Architect. Let's take a look at Chief Architect Interiors. Here is the software, $2,000. Actually, it's not that expensive. It's inexpensive software price, I think. But you can find out this render output easily generated by this tool, 3D library tools. But let's take a look at a little bit about this video so that you can be aware of the difference between using SketchUp, using Revit, especially using AutoCAD, okay? In the lab exercise hours, we're going to deal with homestyler.com, not Chief Architect. But anyway, amount of tutorial video examples will guide you. There are a bunch of more ease of use and powerful tools. That means we don't need to stick to specific software. But anyway, we have learned AutoCAD, SketchUp, Photoshop, and something else. For your final project development, we're going to use something like that. But anyway, today's lab exercise is going to deal with some additional features, additional design approaches, something beyond what we have learned in this semester. Before doing that, for the rest of the lectures, I prepared two different types of examples, digital design and presentation. First one done by professionals, done by professional designers and some actual projects, and done by students, including final project examples. Let's take a look at what are there. First one is a kind of hand drawing based design presentation and actual project. From concept sketch to actual design, a case study done by Gensler, New York. Gensler is sort of world-leading design company, design firm, top one in global market, Gensler. New York office, one of my friends is working in that New York office, and he brought me this Samsung home appliance exhibition example as one of his work done last year. Okay, take a look at this sketch. He drew by hand this sketch. You can figure out the size, dimension of this one roughly, because there is a human being in front of this structure. But this one shows you new Samsung refrigerator, which displays text 80 liters more inside, and easy store, something like that. And on the ceiling, there are some couple of, I don't know how many, but series of displays will show you some fresh material for food and some visually displayed elements. Anyway, this is kind of newly developed Samsung home appliance refrigerator. So he sketched this one, and it actually installed something similar to that design, or also some modification you can find out. But anyway, this one installed in this way. Next example, cool wash new washer. The main feature of this washer is it's cool water enabled. No need to use hot water. So cool wash is main keyword. So he drew this one using the door of this washer. So this door design object, circular shape, is kind of motive for visualizing and making this one exhibited here. So this is actual implemented example picture. Cool wash save energy. And this is 2013 IFA International Consumer Electronics Show at Berlin last year. Actual exhibition for this one. Another picture, and there is series of Samsung booth, and those two examples are two of them, okay? And this one, Jaehyun Park, is the designer for this actual installation, and I like to show you this one, an example drawn by hand, but he scanned it, and using Photoshop, he quickly and easily generate that kind of visualization without any additional complex rendering or something else. Of course, he used computer software too, but he realized that hand drawing based, sketch based representation is very powerful and visually effective. That is why he used that one, and it was accepted and actually installed like that way, okay? Next one is a professional architect design firm, iArch Design, designed this building, Tribals. It's looking like that. Probably some of you visited actual site because it's located in Incheon, Songdo. Concept is simple, tribal, 3 balls. That means 3 different areas near Incheon. So kind of half-cut ball shape. So let's take a look at design process. They adapted reverse engineering approach. At first, they created something like this object as a mock-up model using styrofoam. Very easy to cut object. They made that kind of object first, and they scan it using laser scan device. I'm going to show you what is a laser scan device today. Anyway, they made that one first and scan it and convert it into some freeform and some 3D solid model based software named Rhino and CATIA digital project. So they made this geometric shape, and they print this out when they got some detail. This is 3D print out example. And they iteratively do some geometric optimization process, conceptual design to constructible design. So they made this one because this is design, but the question is how to build this one on site. That's the problem. How to resolve the surface design, make them constructible. So they use the parametric modeling approach, and this is actual site construction pictures. As you see here, total 2,600 individually produced panels, anodizing aluminum panels, covered the building skin. So how to panelize this one in design stage? Designers already knew how many panels needed, and one by one, they have different shape, differently manufactured, okay? That's the point. In design process, they used that kind of parametric modeling tool and subdivide surface and create detailed information using some spreadsheet Excel data so that they can control and change the design phase into construction process. So they got some design award from government, and thanks to that non-uniform shape of building skin, as you see here, building shape is very unique. And interior finish also very different from orthogonal shape, box shape buildings like this way. So without computing technologies, some advanced computer tools, especially parametric modeling and BIM software, it wasn't be easy and very difficult to resolve the problems in construction. Design is okay, but how to construct, how to build the building, that's the main question. And that is why we need to use various different type of software, engineering tools, and some calculation, and so on. Next examples from the book named Idea Design. There are a bunch of similar, several design idea book series, but at this time, let me introduce a newly introduced idea design book published by ANC Publishing. Here is the table of contents: tower, group, box, polygon, circle, organic form. They classify building design in terms of its geometric shape. But anyway, let me show you some example. And the focus here is how to visualize their design, their concepts. Actually, most of designs introduced in this book, they are not yet implemented or possibly not going to be built on site, actually, because this is idea book, so done by designers. The focus here is how to present my idea, my design. Okay, take a look at this picture, this render shot. It's not easy to figure out what it is, but when you see this line-based drawing diagram in 3D, now you can find out those two structures is kind of connection, bridge between buildings on top of existing buildings, something like that way. So we can imagine the geometric shape and the main functional capability of these buildings, structure, and so on. Designed by Pink Cloud, Tana City. How about this one, next one, Digital University, done by Upgrade Studio for specific site, Romania. But anyway, Digital University, take a look at the box shape, cube shapes. This is something like pixel in digital. But at this time, there is voxel. Voxel means 3D pixel, okay? So this one single cube has different function. We can take a look at the size of volume of this cube, and each one has different function, structure, something like that. When we stacking those pixels, cubes, we can generate any type of building shape. Totally different shape you can make them for for the building. Anyway, this diagram, concept diagram, is kind of intuitive and easy to understand. Its function, its shape, kind of building mechanism, and so on. How about this, named ideal tower? When we see this tower building, this one is looking some zigzag style, twisted building. But how about this diagram? There are a series of kind of townhomes. One row can be extracted and upside down and twisted, and then we can generate this kind of thing. And this section sketch will show you, okay, this is something like some city farming or some similar structure without any stairwell or elevators. This is very sustainable and kind of eco, like building structure for city farming. Actually, I'm not sure about the building, but my point here is what kind of visualization they provide and how to capture the major concept and how to figure out the function of that building or the major concept of the building and the visual effect of their visual representation and so on. Okay. Next one, skyscraper city. Okay, you may know skyscraper, series of high-rise buildings. That is skyscraper. But this one looking very different. Why this is skyscraper city? Curious. But when you see this concept development diagram, okay, here is typical skyscraper, high-rise buildings, low-rise buildings, but there is a balloon. This one gonna make some changed geometric shape, and this one gonna be fold in this way. In 3D transformation diagram, okay, series of images will guide you how this geometric shape can be made. That's the point, okay? That is why this is skyscraper city. The last example, take a look at this one, mosque for all. It's not easy to figure out the shape and the main characteristics or concept, why it's open. But let's take a look at this one. Here is a specific building type, mosque. People should get into the building, but designers changed the concept approach. It's kind of upside down. So, extracted similar building shape. That is why this building has this kind of shape. So, this is open, not closed. So, mosque for all, because it's open to public, okay? This shape, geometry, easily, very intuitively and very straightforward, explained by only using this simple diagram, okay? So you need to find out something like this visual representation. Next example, digital design and presentation by additional computing devices. Also some done by professional, but let me show you first example of the laser scan, courtesy by Dr. Yeon-Seok Jung from GS Engineering and Construction. This is laser scanner. This one collects point cloud data from environment, physical environment. I'm going to show you this room example of laser scan. But anyway, using that kind of device, we can collect something like this. Point cloud. The term point cloud means some billions of points generated. Laser reflects some object surface as a point, so computer can collect millions, billions of points. That is why it's looking some cloud. So point cloud is the measurement and observation result. And this is actual building design. Actually, this is not just for building skin design or something. Structural design using steel H-beams. But this is original design, and this is actual measurement on site. So when we get this data, we can realize that, okay, everything is on schedule, everything within design as we designed. But this example shows you one error an error found in this laser scan. They are point cloud. This is design file, but actually this one is unnecessary structure. By mistake of the site manager, they installed that one by mistake. So this one should be removed, okay? There is no crossing H-beam bars, slab, or anything else. So this one should be removed. It takes money, some cost effective, but anyway, that kind of errors can be found using this kind of scanner. Okay, in our building, first floor lobby, last year, Leica brand laser scanner, I invited them and we took this one, laser scan. Over there, we installed this laser scanner and scanned this room. And we have that point cloud data. We're going to use some navigate the model next time, not now. But this one shows you some examples how to get this information. As you see here, this is, you may know this place, lobby area, ATM machine, research lab, and elevator hall, and some couch over there. First lobby, okay? And this is an example, exterior view of this first floor lobby. And this is interior scene of that first floor lobby. Couch area and post and ceiling. Left side is elevator hall, okay? Okay, next example, the first one is digital design and presentation done by students. First one is another example of some hardware, plotter cutter for making a physical markup. What is plotter cutter? I told you we have that plotter cutter over there. This one. This one. The picture represented in the slide is here. This one is much expensive and bigger one. By using this plotter cutter, what you can do, what we're gonna make. Take a look at this example. Use cases. First example, when you create this kind of 3D geometry using SketchUp, thanks to some plugin or some additional software, you can get this kind of unfold structure, unfold map. What if you cut this one by using that device or text? So this kind of structure can be easily generated. Take a look at the model over there. Example pictures are here. Those example physical markup models can be easily generated by that plotter cutter object, okay? Let me show you some text object using this example. This is a final presentation example, 3D graphics, not for this class. Some picture frames. At that time, we planned to print out some photorealistic rendering and make them some picture frame, including some computer still image, so that this one is kind of computer generated, not actual picture. Anyway, in this 6th floor corridor, we take this area, corner space, and we place the amount of rendering images and some computer screenshot images. So at that time, after the final presentation, we put bunch of picture frames like this way and some more example pictures, and the corner will show you this kind of examples. You know this place, upper place, 6th floor from here. And take a look at this text. 3D in real 3D and graphics and some hatched text. All these textual outputs, physical text printed by that plotter cutter. Okay, not this semester, but probably next year we're gonna deal with that plotter cutter device for your physical markup. Okay. So before dealing with this, I think we need to take a break. Okay, please wake up or having a brief nap. Okay, concept visualization example from graduation work. Our department, we have graduation exhibition work. Fourth grade students. So let me show you one example. There are a bunch of more examples, but this is named Brain to Brain, done by Jisoo Kim and Hyunsu Lee last year. The point here is, let's take a look at how to develop, how to visualize concepts and building geometry, and so on. Actually, this is kind of big project for graduation work. But anyway, our focus will be on its visual effects, how to make that kind of effective visualizations. So this is cover page. I'm going to show you some series of presentation slides, okay? The title and some line-based drawing to represent the major aspects of this building, this design. Very linear, as you see here, linear and typical geometry represented in wireframe drawing, and kind of non-uniform shape inside of that building. Okay, the concept is here. Actually, you can take a look at in detail later what is the conceptual approach for developing this design. But anyway, in a nutshell, they developed something organic form, sort of M theory based. I don't know what it is. Some brain related shapes and conceptual approaches they used. So anyway, their project is kind of box-shaped mess, very typical existing building. 2 boxes, actually 3 boxes, and plus their conceptual geometric shape as an interior component. So they developed that shape in this way, and as you see here, 2 box objects and interior object installed in the building. So you can take a look at the progress they made in their design process, and some details, 3D render scenes, interior shots. You can find out some observation for human behavioral factors, and they applied that concept and development approaches onto their design geometry. So certain type of final visualization, even if it's not cutting edge or photorealistic, their focus, they put an emphasis on this kind of organic shape on top of this existing typical box-shaped building. So some additional 3D images represented. And I'm going to show you, I brought this one additionally. This is very typical and simplified rendering output. But for visual effect, take a look at this one. This is same image. From this one, Photoshop retouched visualization is something like this. Some emphasized some lighting effects. And take a look at those 2 boxes in line drawing shape. And interior non-uniform freeform structure is visible in this structure, exactly on top of this building geometry, okay? And some 2D blurred colors and some visual effect applied for making this visualization. to explain the concept, geometric shape, and the inside of that box-shaped building, and so on. So visual effect from using this kind of computer-generated representations, you need to develop something similar for your final project. That's what we need to do. This is actually COSID award-winning work. So actual COSID display pictures, and they got this kind of award. There are a bunch of more examples and more students to take this kind of award-winning work and so on. But for your information, I like to show you this one example, one of the more examples. Final project development examples. Okay, now we're gonna move on to your final work. Here I list up 3 of examples, 3 of your work, total 15. Professional actual design work introduced in Professional Design Magazine, BOB. The first one, Hotel Expo. Second one, Academy of Jewish Museum, Berlin, designed by Daniel Libeskind. Third one, Sleepbox Hotel. Actually, Sleepbox Hotel, this is kind of movable. One single unit can be applied for very different shape of building interior spaces. But this is one of the examples located in specific city, specific place. Anyway, here I list the final project requirements I showed you before. Main requirement is to make your digital design presentation using PowerPoint or Prezi. The problem is how to make your content, not only text, but also amount of visualizations, additional representations. So here I list up specific things to do. CAD drawings, 3D modeling, retouching in 2D images, and some additional images and representations. And Google site should be equipped with your materials. And final presentation, 5-minute oral presentation, and so on. So how to make it? Let me show you how to get through the requirements. Firstly, you have to review given images. I distributed you some PDF files and images and posted on Google site for the course. You have to search by name, search by designer, and so on, by Google image search or just simple Google text search. You can take more additional information about that building, that design. You need to collect as much as you can get from Google. So, and then you have to capture the most important features and the specific site, specific room, specific object, and so on. You don't need to take care of entire building interior or entire building exterior. You can focus on specific lobby space for that hotel or specific object, whatever. But it should be managed by you and modeled by you. Modeling a specific part, even if it's just minor part of that building, anyway, you have to make something visually effective result to present that design. Just simply imagine that is done by you. And what features you have to present in 5 minutes. That's the point. And also you can modify the design because even if you find out some AutoCAD plans or some specific plans, not for everything in that building. It's not easy to figure out specific dimension or material and so on. You don't need to make it exactly the same to existing building. You can modify by your own decision. It's up to you, okay? Finally, you have to generate a bunch of rendering images or screenshots. They should be kind of additionally retouched by using Photoshop or some more tools. Here I show you some examples. This is Hotel Expo example. 3D geometric modeling by using SketchUp. Some rectangular shapes and some box cube objects and some imported components. Series of chairs and some plants. According to this one, you can generate this kind of V-Ray based rendering output. Another V-Ray based rendering output, but Photoshop retouched. That is why this one is looking a little bit photorealistic. One example of a Hotel Expo. Next one is Jewish Museum example. He selected specific part of that building. That building actually very kind of large scale, but this area he picked up and make it some SketchUp materials and geometry and so on. And this is V-Ray rendering output. You don't need to use V-Ray, but it's going to be useful for your final outputs better, okay? Slipbox example. Here is slipbox rendering output. Actually, floor is too reflective and surface is not that good. But anyway, one of the examples you can generate using SketchUp as well as some renderers and Photoshop. This is X-ray view of that slipbox design done by the other students. Using this kind of X-ray view in SketchUp, this is another type of rendering, okay? This is kind of photorealistic rendering done by V-Ray, but this is SketchUp style view. But even if it's style view, this is one type of rendering, okay? Geometric modeling, simply say modeling. When we are talking about modeling, that means geometric modeling, making something from nothing. For that building's geometry, computationally calculated and generated line, surface point, objects, very geometric shapes. But rendering means any type of visualization from that geometric model can be rendering. This is X-ray view rendering. Line stroke based rendering or just simple black line based drawing is another type of rendering, okay? So you can generate this kind of view or V-Ray rendering. So they are all one of your you can use final presentation. You don't need to make hundreds of renderings or images, but at least 10 or many visualizations for your final presentation, 5 minutes final presentation, okay? I told you 10, 15 slides, okay? Anyway, it's up to you, but anyway, not just 5 pages or 100 pages, at least 10, 15, 20 pages, enough, okay? For decorating that kind of presentation slide, you need a lot of this kind of example visualizations. That's what you need to do. Okay, next example shows you progress example. According to this example website I gave you through the course final project description in our course website, you can find out some how to model this structure by series of screenshots of SketchUp. So for this one for Hyundai, for this building, she chose specific area and she made this object and some sequential arrays of this object. You can take a look at how to model this building and assign material, surface, interior finish, some additional objects. Sometimes you can import existing geometry by using SketchUp components or even by Google 3D warehouse and so on. This is one example of your Google site for your final project. You don't need to make too much images, screenshots. This is very good example actually. Anyway, anyhow, you have to present online for your final project presentation. Next week and next after next week, we're gonna have some final project development hours within class as lab exercise hours, okay? So today, we're gonna deal with some additional design tool as the first lab exercise.